Last year, astronomers were thrilled to find the first interstellar object passing through the solar system. There was some confusion, however, about the nature of Oumuamua, initially designated a comet, then an asteroid, and even speculated to be an alien spaceship. However, it seems the initial description was right, with Oumuamua revealing distinctively cometary behavior, giving it a push to leave the solar system even faster. The orbits most similar to Oumuamua's are traveled by visitors from the Oort Cloud, where dirty snowballs circle for millions of years before plunging into the inner solar system. Exposed to sunlight, their ice turns to gas, producing a tail, or at the very least a coma. When all we knew about Oumuamua was its orbital path, it was categorized as a comet. Subsequently, with an abundance of telescopes trained on Oumuamua and no sign of escaping gases, this status was changed to asteroidal. The spaceship discussion occurred because its ratio of length to width was greater than any recorded natural space object, which seemed an odd coincidence. However, attempts to detect radio emissions found nothing. Now, observations of its orbit, published in Nature, support the cometary theory, not because of its already known hyperbolic path but because it sped up slightly in the time we were watching. The gravity of planets constantly change orbits, but these are insufficient to explain everything that happened to Oumuamua. Comets can also travel a slightly jagged orbit when puffs of escaping gas act like rockets, pushing the nucleus in the opposite direction to the gas. Orbital paths can change for other reasons as well. For example, solar radiation applies a force of its own, and that is more powerful when hitting a surface that reflects it than one that absorbs light. However, first author Dr Marco Micheli of the European Space Agency and colleagues have ruled out several such explanations, leaving comet-like outgassing as the last theory standing. We can see in the data that its boost is getting smaller the farther away it travels from the Sun, which is typical for comets, Micheli said in a statement. We might expect that gas is strong enough to alter the orbit of an 800-meter-long, 0.5-mile-long, object would be detectable, but the paper explains this wouldn't be the case provided Oumuamua's ices had very little cyanide, relative to its water, by the standards of comets in our solar system, which have enough poison to have sparked panics in the past. It's less certain why we didn't see any dust particles carried away by the gases, but the authors offer several plausible explanations. What we don't know yet is if the low-visibility cometary features at Oumuamua are the norm in the stellar system from which it came.